So how many of you here have built an API before? Nice, that is amazing. How many of you have built an AI application? Great, nice. And how many of you have heard of MCP before? Nice, awesome, that is impressive. Let's get started. So my name is Aanchal Mishra. I'm a developer advocate at Postman, and I'm super excited to be speaking today about things which I'm really passionate about: AI, APIs, and agents. So let's dive into the talk. Now, we are currently, I think this is much better because it's just, like I'm not sure if I'm coming in between or not, but I'll just stick to this position. So, we are currently experiencing something I like to define as an AI renaissance. And now, this is not the very first time that we are, experiencing a technological renaissance. We have had several renaissances before. For example, the introduction or invasion to computers and programmable systems. Then we had internet and, where cloud became a very big thing. And now we have AI, LLMs, and agents, which are basically changing how we are communicating and building with software systems. At Postman, firsthand, we have been experiencing and we have been seeing this AI revolution. So just to provide you quick stats, last year, AI-related traffic on the Postman platform related to the AI, right, increased by 73%. And this year, it has continued to grow massively. But the big question that comes here is that, can your APIs handle this, And if not, don't worry, let's make it happen. So, to get started and give you some context, that AI agents execute tasks through APIs. But the important thing, or let me give you a quick example in order to understand this better. I'm sorry, I'm going to take you a little bit back, take a little step back and talk about what is a LLM. Not going to promise, I'm not going to go into details. But how many of everyone knows here what is LLM? What? Large language model, right? Everyone knows like this. Okay, fine, we are on the same page. Now, to understand how many of you know what LLM does? What LLM really does? Okay, I see nodding of hands, but just to understand it better, let's play a quick game where what we are going to do is I'm going to give you a phrase, very simple, okay? I'm just going to give you a phrase and you just have to predict the next two words. So whatever comes to your mind, just say the next two words, okay? How is the Josh? Hi, sir, right? No Josh? We are almost at the stretch, right? Okay, all hi Josh. Okay, that is really good. But everyone here collectively said hi Joe, hi sir, right? Nobody mentioned anything different. Why? Because we all have been, we all have either watched this movie, right, where this dialogue came from, or even if we have not, I'm not a movie freak, so I don't really watch movies, but I have seen these movies, I have seen these memes that are shared by my friends on Instagram. So now I know that, yeah, even if someone tells this to me, I'll just know that these are the next two words, that is, hi sir. That is what LLM really does. That is next word prediction. And it not only does this, but it does it really well. Now, Apple basically debugged this recently, where it mentioned that we basically think that LLMs are actually thinking, and the problem is that we are trying to make these LLM or the large language models think. But the fundamental is that LLMs really can't think, they can fundamentally don't think, they will just predict. And with that, I think when I say this, I hope with this background, we are on the same page when I say that AI does not know things. What it does, it is fetches or calls APIs. Now, for example, here if you will see, when I go to ChatGPT and I asked, what's the weather like this weekend in NYC? What it is doing is, it is fetching the weather API, making the API call, and now fetching all the information and basically sending back the response to me in natural language. Again, important thing, it is not thinking. The AI agent here is not thinking, or neither it already knows. What it is doing is, it is basically orchestrating the information which is there and presenting it to us, right, in the response. Now, with that, let's talk a little bit about the reality of AI agents. But before even that, what exactly needs, or what AI agents need? So AI agents typically need three things. One is the model that we already talked about, the LLM, which basically is like the brain behind what the agent there does, and like basically does the thinking part of the, basically it thinks for the agents, right? Next is the context or the instructions, right, that we provide to the agent. And last but not the least is the access to the tools, for example, the data, the API endpoints, and so on and so forth. So I personally believe, and I strongly believe in this, that the teams succeeding with building powerful autonomous systems are not just using better AI models, but what they are doing is they are also rethinking about how their APIs are actually built, or how their organization is basically building the APIs. So with that, an important question arises, and that is, what holds back the AI adoption in the current era? What exactly is holding that back? And the answer to this is as simple as that the models that we are seeing here and all the models that we come across with are really impressive, that's no doubt, but they are only as good as the APIs that they rely on. And if these are not reliable, if the APIs that they are basically working on are not reliable, then they are just like another model, without any useful information that we can fetch from that. So let's talk about what makes an AI ready API. So at Postman we have debunked this, where we have done all the important discussions with all our teams, and we have finalized and we have come out with summarizing 5 critical points which are really important to make your APIs ready for the AI era, or make them ready for the AI agents. So let's go through them one by one. First, your APIs need to have machine consumable data. Just look at this example here that says this endpoint accepts a user ID and returns user preferences. Now human developers like us, what we would do is we can actually like just guess that yeah, user ID might be UUID, and then it is basically resulting, it is basically going to give us a JSON object which will have a key value pair. It's very easy for us, right, to like know that. And if we don't know, then we can just, the best case, we can ask a colleague, right, what exactly does that mean? We have that luxury. But AI agents do not have that, right? AI agents simply cannot do the guesswork, when it comes to giving you the solution or giving, the right answers to that, right? And meaning that because LLMs basically have tons of imagination, because all the data that they are fed on, what could result is that they could also, give us a hallucinated reply, right, which would make the case better, right? So it is very important that your APIs need to have machine consumable metadata. Second, your APIs need to have rich error semantics and introspection capabilities. When I say this, it means just look at this beautiful JSON object that says error, something went wrong. As if I did not know that from the error response code, right? I already know when I see a 4xx error code, I know that something went wrong on my end, right? And when I see a 5xx error, I automatically know that something went wrong on the system's end. But what I'm trying to do here is I want to know what went wrong, not what, like, yeah, something went wrong, not an FYI, right? So this is good, but in that case, something or an error response code like this will be more helpful to an agent rather than just sending a simple something went wrong, right? Because here if you will see, this particular error response code not only mentions what went wrong, but it also explicitly guides the agent on how you can actually solve it, right? By doing simple steps like just defining all the parameters, right, on which our current API is dependent on, or whatever we are working on. So yes, it is very important that when we are working with the AI agents, they should have rich error semantics. Third, your API needs to be predictable and very well documented. Now, remember when I said LLMs predict, right? So LLMs have this feature of where they inherently predict, right, what is the next word in the sequence. For example, if I will see here, as you can see here, right, if I'm able to provide, let's say if LLM does not know something, so it will fetch up some made up information and then, give that response to me, right? Now, making a well documented API, right, basically goes a very long way in order for the LLM to understand what exactly we are referring to when the time comes when the LLM does not know the exact answer to your response. So in that case, this really becomes very important. Now, the next one is inconsistent input is equal to unreliable agent behavior. simple example would be I just go to ChatGPT or any AI agent and I just say that, hey, draft me an email for this, right? And it gives me a response. And then I say, hey, this looks so machiney, you know, like it looks so much like a machine, like writing it. Just make it more human, right? Like, you know, make it more humane. And now the agent is confused, right? So if your input is not consistent and not well defined, it will actually result in giving you unpredictable behavior. Fourth, your APIs also needs to be reliable and fast. 4 points on this. Low and predictable latency. When I say this, it means LLMs do take some time to process the request. That's fine, right? But if APIs also take more time or, you know, become slow and they have lower or unpredictable latency, it will result in a slower response overall, and that is something that we don't want. Next point becomes clear timeout behavior. So yes, if we know that a request cannot be processed or, you know, cannot be successful, it is better to draft our error messages or, you know, tell the LLM in advance that this is something which is not working, rather than LLM having to give, you know, some made up information, and of course resulting in hallucination, which can cause critical issues when, you know, in production, right? Then on top of everything, very important point, that all of this basically has to be dependent on an infrastructure that can handle all of these parallel cases and requests at scale. And last but not the least, your APIs need to be discoverable. Now, all the 4 points that we discussed, if you don't follow that, then there is no point in following that, like following this one. Why? Because AI systems cannot simply integrate with the APIs that they cannot find. So your APIs need to be discoverable, searchable, structured, right? So that AI agents can basically find it and they can actually integrate that on their own without any problem. So yes, with that we have learned about 5 essentials that can actually help us in making our APIs AI ready. And do you think the job is over? No, right? Now what we'll do is we'll basically we will basically add these pointers to AI and AI with function calling. So now let's talk a little bit about that. Function calling or tool calling, what it does is it basically enables LLMs to interact with APIs and external tools, okay? Simple example, here is a diagram. What is happening here is that the user is asking the LLM that, user is asking the LLM that a request that LLM cannot fulfill. So what it does is LLM has this tool or function calling which will enable the LLM to get external information data, because again LLM has a cutoff training data, right? So it cannot always predict the latest information out of it, right? Like it cannot always predict the latest or reply on the latest information which is happening. So what will happen is that this will basically fetch the information as well as do a specific action or perform a function call that can be either an API call or can be a custom function, and then perform that particular task on top of that. So if I'll go ahead and if I have to go ahead and let's say create or build an AI agent, how will I do that with tool calling is like this. So in Postman we have something called as an AI agent block, which basically means that you can technologically build an agent end-to-end from the very scratch using an AI agent block. So here if you will see this is a snap from the Postman flows on our page. So here if you will see, this is a simple flow, which basically means that this is sending a request and then there is an AI agent block. Now what does this AI agent block means is that it has all the different parameters that are there, and what it will do is we don't have to redefine or recode all the APIs and all the dependencies, because what we have is we already have these APIs and workspaces existing in our Postman, right? In Postman. So you just have to add them or import them to the block and we are all good with that. I already have got the 5-minute reminder, so I'm just gonna skip this and I'm going to come to this one. But this is still important. If I were to build a similar agent, right, without an AI agent block, it will look something like this, which is really huge. It is messier because of course it has to go through different levels of layers, API calls, and so on and so forth. And this is the same workflow as this one. which is just reduced to one single AI block. So that's why do it with Postman. Now, couple of important pointers around Postman if you are already not aware about this, I'm assuming. First of all, Postman is the largest public hub of APIs where you can find more than 100K 100K APIs which are publicly available for you. Second, we have which is basically also like a global discovery. So all your APIs or all the APIs which are present here in the Postman API network are global. You can use them, you can fork it in your collection, you can fork into your repository, and then you can work with them. Next, there is also something called as verified publishers at Postman, which means if you are a developer who is building a lot of APIs, you can actually get yourself verified on the Postman API network so that people know that yes, you are a genuine developer and you have these list of APIs and they can discover it live on the Postman API network. Next one is collections. Collections is, again, I think you all must be using, if you are using Postman, then you already know what is collections. It basically lets you define, group, and make all your API requests in a very compact format, right? And this also serves as an example for the AI agents when you are teaching them, right? Because these are really grouped, well-defined, and with all the set of examples and everything added. So, if you want to become, a verified publisher on PAN, you can actually just scan this QR code and you will get all the information on how to get yourself verified onto the Postman API network, and you can do that easily. And yes, your APIs will be listed live on the Postman, on the PAN. Now, so what we have done so far, first we made our APIs AI ready, and we also enabled tool calling to invoke these APIs. Now let's talk about the elephant in this room, that is MCP, and let's understand if my APIs are really going to, like replace, or basically MCP is going to really replace my APIs. Now, understanding MCP, I like to explain this with my favorite example, that is USB Type-C of the AI world. So we all know, right, before USB Type-C was introduced and was introduced as a standard into the world of connections of devices, right, we all had countless number of devices, each with different sets of cables and connectors, right? And when USB Type-C was standardized, right, thanks to European Union, all the devices could actually be easily connected and was compatible with USB Type-C. Also the Apple products, right, which were the longest resistant one, who were not adopting the USB Type-C, they also finally adopted it, and now we can actually integrate, use USB Type-C in with our, with our, with all the devices, with even Apple products. So similarly, in this case, if you will see before MCP, here if you will see, this is our LLM, and then we have different types of APIs and services which it is dependent on and which is basically it is working with. Everything looks good until we want to do some change, or we want to make some changes. For example, let's say I have a better model and I want to change to that. What can I do? In this case, it is going to create a very big problem. Why? Because I have, for example, here is only 3, but I'm sure that whenever we are working with any model, we are working with at least 10 or more than that, like more than those services, right? So if I want to change the model, what will happen is I will have to write the integration code for all of these, because they all come with their custom code, right, for integration. And that will be a huge problem, because the more services I'm using to make my application better, the worse it is doing it for me, right, in the backend. And now, when we have MCP, it basically acts as a universal adapter, like USB Type-C, right? So what it does is it basically, we don't have to really worry about the different types of n number of services that we are using, or if we want to replace an LLM model, it can easily integrate and smoothly work with any AI integration without having to worry about the integration and custom integration for all the different types of services. So yes, next steps on your journey, I know I'm already on time, but I'm just going to quickly cover these. Start small, focus on single high-value API. Rather than building multiple and tons of APIs, focus on one and try to incorporate the 5 essentials that we saw into one high-value API. That will really result, and that will really go a very long way. Discoverable, I think I have talked about this enough, that your APIs need to be discoverable for consumption, because AI agents cannot simply integrate, if they don't know that your APIs exist, right? Then AI first, this may be the most significant mindset that I feel is going to change the, it's going to change how we work with APIs, is that when you basically architect an API that works seamlessly through AI, with AI through MCP, that you will find it even better for human developers. So it's not just for AI agents, but it also goes a very long, it also is very good for the human developers. And from now, where we go from here. So for decades, APIs have been primarily viewed as these plumbing technical, technical implementations where it basically connects different types of system. But with the MCP era, what they have become is that they have basically become something more strategic, because now they are the primary interface through which AI understands and interacts with your business capabilities. Now, next one, I really wanted to show a demo as well, but I know I'm already out of time. So what I would like to recommend is that you can actually head to getmcp.dev, and you can actually find a very nice MCP server collection for trying it out, where you will actually see how you can discover different types of APIs. Within just a click of button, you can convert them, you can generate an MCP out of it, and then you can connect it with the LLM, and then that will be really great. And yes, that's it. That was the wrap. Thank you so much for attending. And yeah, you can connect with me on Twitter, LinkedIn, or the best way is just scan this QR code. This is for the link tree, and all the links to my socials are available here. Thank you so much. Yeah.